Integration by parts can be done when you have two terms inside of the integral that are being multiplied, and it's going to be used when u sum does not work. So if you're trying to solve a problem that's in the form u times v prime being the same thing as dv dx, this is going to be a problem. The solution is going to be in the form u times v minus integral of u prime, which is the same thing as du, times v dx. This is going to be your solution when using integration by parts. So the first thing we want to do before integrating is to find our u value. And to do that, there's a priority system, which is represented by the acronym LI8. So the first order of priority is going to be L, which is for logs. Second is going to be inverse, trig for I. Third for A is going to be algebra, preferably polynomials. Fourth for T is going to be just regular trig. And last at the bottom is going to be exponential for E. So that's how we're going to choose our U value. Let's take an example. Let's say we want to find the integral of x times e to the power of x dx. So here we have two terms. You have x and we have e to the power of x. And we know that x is an algebraic term and e to the power of x is an exponential. So if you look back at our acronym, we can see that algebra is of a higher priority. So we're going to choose that as our u value. So u is x, and our dv value, which is going to be the rest that is not u, that's going to be e to the power of x dx. Then the two other things we want to find is du, and we want to find v. So to go from u to du, we're going to derive, and to go from dv to v, we're going to integrate. So to find the derivative of u equals x, we're going to take the derivative. So du dx is equal to 1, and we're going to multiply both sides by x dx to isolate du. So we'll get our final answer as du equals dx. Then here we're going to integrate e to the power of x dx to get v, which is just going to be e to the power of x. So now we can go back to our formula and just plug all these values in. So we're going to start by doing u times v. So we're going to do x times e to the power of x. I'm going to subtract the integral of u prime times v dx. So we know u prime, which is du, is dx, and v is e to the power of x. So we'll just multiply those two together and get that. Now we want to finally solve this integral to get our final answer. And we know that the integral of e to the power of x is just e to the power of x. So our final answer is going to be x times e to the power of x minus e to the power of x plus our constant of integration, and even more simplified, this is going to be our final answer. Now there's one more method of integration by parts that is a bit faster, which is called tabular. Tabular can only be done when the u value can be derived to 0. So let's take an example. Usually we'll use tabular when we have an integration by parts problem that would require us to integrate by parts 2 or 3 or more times, and tabular makes it much faster. So let's say we want to find the integral of x squared times cosine x dx. So first we want to find our u value, and we know that x squared is algebra and cosine x is trig. So if we look at our LI8 acronym again, see that algebra is higher. So we'll use x squared as our u term. So u equals x squared, and the rest is dv, which will be cosine x dx. Now from here we want to make a table of values in which the left side is the derivatives of the u term, and the right side is integrals of the dv term. So we'll start with our initial values. We have x squared and we have cosine x. And we want to derive the left side all the way as many times as it takes to get to 0. So first we'll take the derivative once, use the power rule to get 2x, then we'll derive again to get 2, and finally we'll derive another time to get 0. And we're just going to integrate however many times it took to reach 0 for the right side. So we'll take the integral of cosine x, which is sine x, then we'll take the integral of sine x, which is negative cosine x, and finally take the integral of negative cosine x, which is going to be negative sine x. So now we can put all these terms into one final expression, and how we do that is that we cross multiply, starting from the left and go one down, like this. And we're also going to remember to switch signs every time we go to a new term. So we'll start with a plus, then we'll go to a minus, then a plus, and then a minus. So now we can multiply these terms together and add them all to get our final expression. So we'll start with this term, which is going to be positive. So it's going to be x squared sine x. Then we'll go to the second term, which is going to be negative this time, minus 2x times negative cosine x. Then we'll go to our last term, which is going to be positive, plus 2 times negative sine x. If we simplify all this, we'll get our final answer as this. And tabular is much faster than if we were to do this integration by parts problem using the original formula like this.